Hello, ladies and gentlemen. So this week we are going to learn all about periodic table. We're going to dig deeper about how periodic table is organized. So let's get started. So while you're watching this video, this is a video instruction of the periodic table concept 3 notes. So I need you to take down into your guided notes the information that you see in this video. You can turn this in by the Saturday night. So whenever you have time after you're done with the small part of your project this week, I need you to take some notes, small part by small part every day. Okay, so don't feel overwhelmed. These notes are going to help you to study for the tests and help you learn even more than just watching it. Okay. All right, so what is a periodic table? So you guys know that we touched base last week when we were talking about the elements and the structure of them. So a periodic table is a table organizing all of the elements known to exist by atomic number and chemical properties. So we're going to see how they are arranged by their chemical properties and how they're arranged by their um, the number of shells that they have. So let's start with the groups. So groups are the vertical columns on the periodic table. All elements in the same group have the same number of valence electrons. So if the elements are in the same group, in the same column, these are all having the same number of valence electrons in their outermost shell. So you got to remember, what do we call the electrons in the outermost shell, the outermost energy level in the electron cloud? We call them valence electrons. Remember that, okay? So for example, group 1 has one valence electrons, group 2 has two valence electrons. Just skip the transition metals because they sort of different way to figure out their valence electrons. And group 13 has three valence electrons, okay? And 14 has four, 15 has five, group 16 has six, group 17 has seven, and group 18 has eight electrons, eight valence electrons in the outermost shell. If you just remember the Bohr atomic models that you drew before, so you will remember how to arrange those electrons in the energy levels in the shells. Okay, so yeah. So with the exception of helium, all the group 18 elements, they have eight, which means full. All the seats are filled, all full eight valence electrons in the outermost shell. Because of this, because of the same number of valence electrons in the same group, they have the similar chemical properties. So yes, number of valence electrons are related with having similar chemical properties. So group names to know. So group 1 is called alkali metals. They are the most reactive metals. For metals, reactivity increases as you go down the group. So the last group on the group 1 has francium. So francium is the most reactive metal because reactivity increases as you go down the group. This is only for group 1 alkali metals and other types of metals, but the francium is the most reactive metal among the all metals. It doesn't include hydrogen because hydrogen is a special element. Just because it has one proton and it has one electron in its shell, it has only one shell, it's considered as in the first group, but it has totally different chemical properties and physical properties other than the metals. Group 2 is alkaline earth metals. Group 3 is called rare earth metals. Um, so remember, the group 3 is considered as transition metals, also called as rare earth metals. So group 3 through 12, right at the center of the periodic table, is called transition metals. I'll show you the periodic table and I'll repeat these just in a second. So group 17 is halogens, is named halogens. Halogens are the most reactive nonmetals, and reactivity decreases as you move down the group. So it's like oppositely to the alkali metals. Halogens are the nonmetals and their reactivity is decreasing as you go down the group. So the first element on the top in group 17 is the most reactive nonmetal, which is fluorine. Okay. Group 18 is the noble gases. They are non-reactive elements due to already being chemically stable because their outermost shell is totally filled up. All the spots are filled. They don't need any elements to react with because, again, they are chemically stable. It's like they have a full stomach. They don't need to just get interactive with any other elements. That's why they're called noble, because they're rich and they are already stable. Okay, so let's get to look at this periodic table. So the first group is group 1 has, they are all having one valence electrons in their outermost, and these are called alkali metals. Okay, and then the second group is called alkaline earth metals, the orange one. They have two valence electrons, and at the center we call these transition metals. So group 3 through 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 3 through 12 is the transition metals. Okay, we can't tell how many valence electrons each has just by looking at the table. So there's another way of knowing that. You will get to learn this in chemistry. I don't want to expose you too much information with that. So let's continue. Boron group. So the first element is boron, so that's why we call this family boron family or boron group. They have all three valence electrons in their outermost shell, and the carbon group has four valence electrons in their outermost shell. So carbon, silicon, germanium, tin. Tin is also known as like the can, the tomato can, soup cans. These cans are made out of tin, by the way. And then the lead, okay. So these are all having four valence electrons in their outermost shell. And the nitrogen group, they have five valence electrons. They're in the 15, group 15. And the oxygen group, they have six valence electrons in their outermost shell, and there's called oxygen group. And halogens have seven, and noble gases have eight. So noble gases are the non-reactives because they don't need to react because their outermost shell is already filled up with all maximum 8 valence electrons. So there's no more seat for other electrons to come and sit in their outermost shell. So that's why they're non-reactive. They don't miss any electron. They don't have excessive electrons. They have already filled up. All right, so let's move on. Period. So now, so far we've been talking about groups, the columns. Now it's time to talk about the periods. So periods are the horizontal rows on the periodic table. All elements in the same period have the same number of energy levels in their electron clouds. So for example, look at this picture. Look at this Bohr model, not just a picture. So this, we don't know what element is this, but what we know is it has three shells. So if it has three shells, what period is it's in? What period is located? Period 3, because it has three shells. So this is the relation between the period number and energy level number. Okay. All right. So electron clouds are broken down into shells or energy levels. We know that, right? So that each hold a certain number of electrons. So we may not know this. So make sure your ears are on. So level 1 has maximum 2 electrons. Or I might have recorded a voice message for your Bohr atomic model worksheet last week. So if you remember, yeah, that's going to be a kind of repetition if you remember my voice message. So level 1 is the closest to the nucleus. So this one has maximum 2. And level 2 has maximum 8. Level 3 has maximum 8. Well, sometimes it can hold up to 18 electrons, but again, this is for transition metals. So transition metals can hold up to 18, but if it's not a transition metals, it's not locating at the center. It's like if it's not locating here, okay, then they can get maximum 8 in the outside, in the third shell. But if it's a transition metal, they can get up to 18. That's what makes them transition. They can have maximum 18 in their third shell. Where was I? Where should I go? I'll just go this. All right. Okay. So And then the fourth level can get maximum 18. So here's our how the energy levels look like. So the first energy level, second energy level. So the second period can have 2 energy levels. Third period can have 3 energy levels. Fourth period can have 4 energy levels. And fifth period can have 5 energy levels or 5 shells, and so on. Okay. So atomic structure in the periodic table. An element's location on the periodic table informs us about its atomic structure. For example, this is a magnesium, right? So I'm asking you, how many shells do you see? One, two, three. 3 shells means what is the period number? 3. So this locates in period 3. And just by looking at the valence electrons, the red ones, outermost, look at the outermost shell, it has 2 valence electrons. So remember the number of valence electrons represents the number of group. So which group number it's in? 2, right? So group 2, and because it has 2 valence electrons, and that locates in period 3 because it has 3 shells, 3 energy levels. Okay, so let's talk about how the periodic table is divided by the classification of elements. So there are 3 types of elements: metals, nonmetals, or metalloids. That's why these colors are different, like blue, orange, and purple. So the blue ones, or just teal color ones, metals. These are all metals. See how many? There's like more than 3/4 of the periodic table is made out of metals, right? Classified as metals. So what are the properties of metals? They are shiny, silvery solids. They are great conductors of heat and electricity. They are malleable and ductile, and they're located to the left of the metalloids. So metalloids are the orange ones, as you can read the color code. Okay, the orange ones are the metalloids, and the purple ones are nonmetals. Okay, so let's talk about metalloids. So metalloids are solids. They are semiconductors. That means half of their properties show metals and half of their properties are showing non-metals. Like they're both metals and non-metals. Why? Because they can look like shiny, but when you try to break it or try to bend it by the hammer, it's like breaking down into pieces. So it's brittle. Okay, you can't bend them. They don't show malleability. Like you can't bend them, or you can't just turn them, like make them flatten. So that's why they're called semiconductor, and they conduct less than metals. Okay, and their physical properties like metals, and then chemical properties like nonmetals. How about nonmetals? So nonmetals are gases or dull, brittle solids. That brittle means like when you try to when you hit with a hammer, they're gonna broken down into little pieces. That's why they're called brittle. Okay, they are poor conductors. They don't conduct the electricity. Well, when you connect the wires, when you make a circuit with a light bulb, and when you put a piece of, for example, when you put a piece of fullerene or or sulfur, they're not going to conduct electricity. Okay, they're going to conduct very, very low electricity. Right of the metalloids. So on the periodic table, they're located at the right side of the metalloids, with the exception of helium. Okay, I'm sorry, with the exception of hydrogen. So hydrogen is not among them because it has only 1 electron in the outermost shell. That's why it's considered in the group 1. It's located in group 1 because it has only 1 valence electron in its outer shell. Okay, so we know how to draw Bohr models, right? You guys get to know that. So Bohr models are simple diagrams that show the atomic structure of an atom. For example, this is aluminum. It has 13 proton and 13 neutron. First energy can get 2 maximum, and then the second energy level can get 8 maximum, right? And so far we have 10, and we have 3 left because 13 proton means 13 electrons we have to place. So the last 3 electrons have to be on the third energy level, right? You cannot jump to the third before filling out the second energy level with up to 8. So there must be 8, then you can go to the next one. It's like the movie theater, the rows are filled up with electrons, and there's no more seat, you can't put people on top of each other. So you have to put the rest of the electrons after 8 and the third one. Okay? But make sure you keep checking the number of electrons though. People can put like 2 here and 8 here. Oh, I have like 8 so far, so I have to put 5 more in the outer shell. No, you're wrong. You have to keep counting how many in total every time you place the electrons so that you can check if it's 13 in total. So these are the steps for you. I need you to read this and fill out your notes accordingly. So there's pink and blue and purple. These are like the blanks in your guided notes. So make sure you read and try to understand how to draw the Bohr atomic models. All right. So yeah, that's all about it. Hopefully you guys understood really well about the periodic table and the classification of elements.